Hello everyone. I'm really happy people are joining. We are going to start in a couple of minutes. As always, we are going to do some C++. I have lights. I can change the color, I think. It can be blue today, if you prefer. Um, yeah, sorry, no content warning that you may see some flashing lights or something else. So yeah, you may expect. I think green was better. Oh, yellow was better. It's like a little bit warm color. Yeah, I have like several colors. I usually use this one, but sometimes I change. And because I'm color blind, I don't know which one I will turn next time. Uh, let's hope this is better. Anyway, um, how people doing today? Everyone enjoying a long weekend? And it's not long, but I guess it's slow. What kind of color blindness? So I don't remember exactly the name. It's like something related to red and green colors. So you know, there's like these tests where you like dots, in like little small circles of different colors, and you're supposed to see a number or letter. So I usually fail at those miserably. Although, like I would say, I see colors when they're different. Like if you put two colors nearby, I can see them like that they're different, but not immediately. And when colors, let's say my tolerance threshold for color difference is a little bit higher. So let's say if it's like green or red, I might not immediately see it unless they're nearby and I have to compare. It's like imagine if you have like two JSON files screen by screen, and like you see one file and another, and there is one type on them, and you need to find it. So if you look at them closely, eventually you will find it, but not immediately. Uh, so it's this kind of color blindness. Just spend weekend learning a camel. It's really similar to F sharp. Uh, yeah, a camel and F sharp they're kind of similar. So a camel appeared first, and then F sharp got really inspired by a camel. So actually, the first F sharp compiler is just a fork of the camel compiler. Maybe it is actually is now. So they forked and they started writing patches at some time on top, as they just switched runtime to .NET runtime from the native. But yeah, lots of inspiration, and it's really good when you know one language, you always know the second one for free. But today we are not going to do OCaml or F sharp. I'm sorry for people who joined stream. We are going to do functional programming anyway, so I hope at least this will console you. So um, let me actually start, so we don't spend too much time on this. So, hi everyone, again, people who join, and just for your context, this is what we are doing on the stream right now. I'm going through this Haskell course, which is SYS194. I don't know what it means. Some people asked during the last chat, what does it mean? Sorry, I haven't done my due diligence. I haven't tried to Google to understand. But anyway, this is a Haskell course. I did it 10 years ago, not in 2013 and not in that university, just in my free time. But it really worked for me in terms of like understanding how functional programming works. And on this stream, I'm going through this course, but in C++. So apparently, C++ has a lot of functional features. Um, and I just want to see how feasible it is to do like pure functional programming, or not pure, but like the functional programming in C++. So I'm just going through homeworks here. We already done homework 1 and homework 2. I'm uploading videos to YouTube, so you can find all of the recordings on YouTube. Today we are going to do homework 3. I hope it will be like a small one, not really difficult, so shouldn't take too much time. And again, Feel free to ask me anything in the chat anytime. I might not see your questions immediately. I'm streaming me with one screen. It's a bit hard to keep up with questions, with coding while talking and all of the stuff. But yeah, ask any questions. I'll try to elaborate, and we're just going to walk through these problems. Yeah, let's start. So homework 3, code golf. This assignment is simple. There are 3 tasks listed below. For each task, you should submit a Haskell function with the required name and type signature, which accomplishes the given task and as short as possible. So first of all, this course is in Haskell, but we are doing it in C++, so we are not going to submit a Haskell function, we're going to submit a C++ function. Second, I'm pretty sure everyone knows, but code golf is kind of like this term for trying to write the code in the shortest way possible. Like, do you know standard functions good enough? Do you know features good enough? And are you creative enough to kind of write it in the shortest way possible? So it's kind of like, like a hobby, like an interesting activity. Can you like squeeze the maximum out of language? How good is your language, and how you try to minimize the function as much as possible? And it's kind of like, it can be fun, like for exercise. It's definitely not really for production usage or when you work in teams, because what's important is that others can understand. Sometimes the shortest solution is the simplest one. Like if you want to add 2 numbers, you're just going to use the plus operator. You're not going to write a while loop and incrementing one number by 1 and decrementing the other by 1 while the other one is not 0. Like the shortest solution is the solution, but sometimes shortest solution can be really hard. We are writing in C++, so the shortest solution doesn't mean anything. We will try to write something reasonable, and hopefully using functional programming, we will be able to write it good enough, like in a declarative style. Okay, rules. I like rules, especially ones that make sense. Along with your solution for each task, you must include a comment explaining your solution and how it works. Solutions without an explanatory comment will get a score of 0. Okay, this is harsh. I will try to explain my solution on the stream. Feel free to rate my solution like anytime you see. Like if you think I'm explaining well, just chat 0. Put 0 in the chat. I'll do better next time. But anyway, yeah, people ask me on Twitter, where comments in my code? Like I'm not ChatGPT. I'm not going to comment every line of code. I'm recording like this hours of video with commentary. Yes, exactly. Cursor with explanatory comments. I think Cursor would be like really well for these tasks. Yeah. So imagine if you were reading code and like some legacy code and you don't understand, and there was an option to kind of just listen for 2 hours ASMR of a senior engineer explaining how this code works, what's happening. I think it would be great. So people should appreciate streams and like this voice commentary. Anyway, your comment should demonstrate a complete understanding of your solution. In other words, anything is fair game, but you must demonstrate that you understand how it works. If in doubt, include more detail. Anyway, as again, if you don't understand anything, just write something in the chat, and I will try to explain more. Comments do not count towards the length of your solution. Type signatures do not count towards the length of your solution. Import statement do not count towards the length of your solution. Okay, I get it. Good. You may import any modules included in the Haskell platform. God damn it. Can I use C++ modules? That's going to be hard. White space does not count towards the length of your solution, so there is no need to show all your code into the line and take all the spaces out. Use spaces as appropriate, indent nicely, etc., but otherwise try making your code as short as you can. Again, this is for this task, this mostly means, like, because it's teaching people how to use Haskell, it mostly means try to use standard function libraries, don't try to reinvent the wheel, don't try to unnecessary do things. In Haskell especially, try to use like currying and partial application in all of these nice features, so just don't introduce extra code. You are welcome to include additional functions beyond the ones required. That is, you are welcome to break up your solution into several functions if you wish. Indeed, sometimes this may lead to a very short solution. Of course, such additional functions will be counted towards the length of your solution, excluding their type signatures. Your final submission should be named golf.hs. Your file should be blah blah blah. Okay. The three shortest solutions, counting the total numbers of characters, excluding white space and the other exceptions listed above. For each task, you will receive 2 points of extra credit each. You can get up total of 4 extra credit points. Okay. Since I'm the only one submitting in C++, I guess I will get all extra credit points, which is nice. Otherwise, the length does not really matter. So why it doesn't matter? Like, you try to explain all of this, try to do shortest, and then it doesn't matter. Long but correct solutions will receive full credit for correctness. Okay, at least we still care about correctness. Like, it's not about shortest and elegancy and performance. At least correctness is good. Hints. Use functions from the standard libraries as much as possible. That part of the point of the assignment. Using the same map is much shorter than implementing it yourself. Yeah, that makes sense. In particular, try to use functions from the standard libraries that encapsulate recursion patterns, rather than writing explicit recursive functions yourself. Okay. You may want to start by getting something that works without worrying about the length. Once you have solved the task, try to figure out a way to make a solution shorter. If the specification of a task is unclear, feel free to ask for clarification on Piazza. Damn, that's a really nice option. You can just go on Piazza and ask a solution. I don't know if it's like name of legacy service or it's literally like some course in university and you can just professors don't have any job. They're just walking around Piazza. You can just find them and ask. What a nice opportunity. We will test your functions and other inputs besides the ones given as examples. So be safe. So should you. So to be safe, so should you. Sorry, my English is not English in today. Anyway, let's start. Exercise Hopscotch. Exercise 1, Hopscotch. Your first task is to write a function. Okay, I think I can do that, chat. So, Piazza is a website. Okay, good to know. So, once something's even like older than me, can believe it. Anyway. Okay, I'm not going to write f function. There is more to the task. So the function skips with this type signature. The output of skips is a list of lists. The first list is in the output should be the same as the input list. The second list in the output should contain every second element from the input list, and the ends list and from the output should contain every ends. Okay, I get it. Basically, a picture worth 1,000 words, or more like an example. And skips says so, like, first we skip every like 0, so we get all the lists, then we skip every second, so second and fourth, BD, then every third there is only 1/3, and every fourth only 1/4, and with a string and with numbers and with booleans. So basically write a function that takes a list and produces a list of lists where on every element it's like a list of skipped. So a few notes to people confused. So this type signature means that we take a list of lists and we take just a list of anything and we return a list of lists. And you can see that it doesn't matter what this function, like what the input value, what the input of the list. It can be list of numbers, list of booleans, list of characters. So yeah, in Haskell strings are actually a list of characters. That's why this works. So kind of string is a list of characters, which is not really efficient, but sometimes easy to write code. And yeah, we just get a list of anything and we return a list of lists. We don't do anything with elements specifically, so this function is polymorphic. It works with everything. And we are going to write something like that in C++. The questions in the chat. I am C++ian, if it makes sense. In the context of this Twitch stream, that's the only thing that matters. Anyway, let's jump to the code. I already prepared like another directory with homework and just some basic files with CMake and stuff. So we have print line And by the way, this is how you do hello world in modern C++. We no longer need to use um, std out or like student line, whatever. I think we can just use print line, and it is more powerful. It has more features than cout, and we are going to look at them today as well. Yes, there is actually a book about functional programming in C++. Some people recommend it to me from time to time. I haven't read it actually. Not sure if I can learn more from it. But yeah, once I have time, it sounds like a great book to read. Anyway, let's write function. The function is skips. In the Haskell signature, it takes a list of anything, but we are going to work with vectors just for simplicity. So I need to include vector. And usually, like when you pass vector, you pass it by reference, by const reference. So in this case, we're not going to mutate vector. We're not going to update it or change it. We just wanted to read content from it, and we will pass it by reference. So we don't need to copy the entire thing. Basically, when you have huge data structures, it's easier, like it's better to pass them by reference. So like you don't pass the direct value. Anyway, and the vector, like we specify a vector of what, and like Haskell solution is polymorphic, and let's try to be polymorphic as well. So we actually don't care what's the vector, so we are going to use polymorphic. I'm not sure I used templates before on this stream, but basically this is how you do it. You write this template function, you have parameters, so if you have multiple parameters, you just introduce more of them, but I have only one parameter, and I say that I have a generic vector of t, and it's a reference to a vector, so I'm not passing this, and this is the argument. So my function skips, takes a reference to vector of something, doesn't matter. It can be vector of integers, vector of doubles, vector of strings, vector of vectors, doesn't really matter. And we need to return, again in the Haskell version, list of lists, but in the C++ we will do vector of vectors. So I'm going to return vector of vectors and of the same type t. So basically with this type signature we kind of couple together. So the types that you have here, it will be exactly the same in the result. We are not going to change anything, like update the types, suddenly change into double or whatever. We are just going to do this. Okay, Garen, go to church. Church is more important than C++. Well, I think both C++ and church have crosses, so I guess it can work, but anyway. Thanks for joining anyway. Not ranges, so I'm not going to return a range. I think my range knowledge is not that advanced yet to write something polymorphic over any range. I think generally you do want to do this, and by the way, all of this code will be on GitHub, so you can try to follow it, kind of start from this as a blueprint and update to ranges. Maybe at some point I will do this as well. I think it would be great. And by the way, let me just send the link to the course that I'm doing, if anyone wants to follow. And this is the solutions. Okay, anyway, this is what we are going to do. So how I think about this problem. So we have I'll write something in the comments. So let's say I have a vector 1, 2, 3, 4, 5, 6, and I want to return a vector where I skip nothing, then I skip every second element. So I take every second element, then I take every third, and so forth up to the end of the length of the vector. So the way I think about this problem is that, okay, I kind of have a sequence of how many I want to skip. Like I want to skip 1, 2, 3, 4, 5 up to the size of the vector, and then each number in this sequence, it kind of transformed to the corresponding result. So the number 1 corresponds to vector we skipped every number, the number 2 corresponds to vector skipped with every second number, and so on. So in functional ways, about like transforming data, this is what I want to do. I want to get the sequence of numbers and I want to transform it on every step. Am I new to programming? Well, depends what you say. I think someone said that I've been writing only for 20 years and I still feel like I don't know anything. So you can say something like this. Functional programming in C++. I mean, maybe I am actually new to programming. I started with functional programming C++ because if you would be good at programming, you would realize, okay, it might be not a good idea. Let's not do functional programming, but immediately jump into functional programming C++. It's really great. But yes, someone mentioned std iota, and this is exactly what I'm going to do. I'm going to generate a sequence of numbers with std iota, and for this we need ranges. So I'm going to include ranges, and so actually this function will be really simple, and in Haskell I would say like one line, but in C++ it will take more than one line. But indeed, we will start with std iota, and std iota is a generator of numbers. I think the constraint is something that can be incremented, but basically I want a sequence of numbers, and this uses like ranges, and it generates like numbers, and it actually can generate the infinite sequence. So if I say that just this std iota of 1, it will generate infinite sequence of numbers 1, 2, 3, 4, 5, and so on. But because it's lazily evaluated, so ranges in C++ they're lazy, it won't actually like generate them on top unless you try to print them and then you won't finish. But here I don't want an infinite sequence of numbers. I actually want just a sequence from this to vector size. And I think due to some polymorphism and some type inference issues, it might not work. So let's actually okay, I will need another more statement. Let's actually produce separate variable and do its type as integer size. So this will generate all of the numbers from 1 to the size to size minus 1. So if this vector it has size 6, this will actually generate numbers 1, 2, 3, 4, 5, but not 6. So actually here I want size plus 1. So I want slightly bigger size. This will be the exactly sequence I want to do. So this way we kind of generate the sequence of numbers. Now I want to transform every number into kind of like skipped elements. So this is what I'm going to do. I'm going to use std transform, and this is kind of like map in Haskell. So I map every element, I transform every element, and here I can just pass lambda. So I'm saying that this is number n, and inside this lambda I need to return something. So this is like pipe operator. This is how in C++ you can actually pipe ranges. It's like a bash. If you ever wrote bash or like any command in shell, you kind of get the input of one stream and you just pipe it to another. And this way you operate on every, so transform function will just operate on every single element. This is like sequence of numbers, of integers, and I can update them. And I want to transform every number to kind of to vector of those numbers skipped, like of elements in those numbers skipped. And so like I want some function of vector. I want to do something with vector. So first of all, vector is an argument to our function, but lambdas in C++ kind of strict. They require to specify explicitly what you need to get externally from the lambda. So I'm going to do it like this. So in this square part, which is called lambda capture, you can specify what lambdas have access outside. And here I'm saying that I'm passing a vector by reference. Again, I'm not copying because copying is expensive, and I have access to the vector so that I can use it inside. And here I can do whatever I want with the vector, and basically I want, now I kind of want to write a function that, given a vector and a number, it takes every element of this vector. So there is actually a standard function in C++ to do exactly that. We got really lucky this time. Let me just show it. So this function, it's right. Let me increment a little bit. Let me zoom in. So this function stride, it actually does what we want. So usually there are like examples and I read them. So there are like views it. Okay, I will probably have to write views, not just iota. And if you just pipe it to stride, it takes every third element. So here we have like sequence of numbers 1, 2, 3 up to 12. And the output in the first example we see we have 1, 4, 7, and so on. So it actually, so we see first thing. So basically this is almost what we want. It just takes every nth element, and we can map every number to basically to this stride. So if you go back to the code, what we can do is almost this pipe to std view stride n. But as you've seen, this like stride, it returns the first element of sequence as well. So like if vector starts with some element, we will get element 1, and we need to fix this. It's actually easier to demonstrate with an example. So let's get back to it and fix it. But let's assume here we just wrote a function that just converts every number to a vector of vectors. So now we kind of have basically almost what we've done. We use standard functions and we support it. The only thing is that this stride, it doesn't return a vector. So here we want to have like a vector of vectors, but it is itself doesn't return a vector. So what we can do like another transform, and here it just passes some range. I don't care what's the range, but I'm just saying it's RNG, and I want to create a vector from this range. So basically what I'm doing is I'm creating a vector with range begin and range end. So range is something that has iterators begin and end, and the vector has a constructor that just takes two iterators begin and end. And you can just create vector from this. So I don't want just the range, I want iterator. I think in modern C++ you can pass range directly to the constructor. I think it should be able to construct it just from the range. We can try it later. But basically this is what we did. We converted every range to this to vector. And now I like externally this is a range. So I had range of ranges. I now transformed it to a range of vectors, and now I want a vector of vectors. So again, there is this like std ranges 2, and it allows to do what we want. This is basically kind of like the final assembler pipe. If you ever wrote like Java, before it was like stream collect or something similar. On line 14, can I do std vector? I can do that, yeah. For the sake of like code golf spirit of this, we can try doing that and try to minimize our solution. But I think this is kind of the complete solution. So let's actually try to verify that it works. I'm going to create the vector 1, 2, 3, 4, 5, 6, and I am going to actually just iterate through skips and see how it prints it. So let me separate it from the rest. Out skipped and skips vector. Just going to do line skipped. Even this. So one thing I wanted to mention about print line in C++ is that now you can actually print just the entire vector easily. You don't need to like separate it by whatever, anything. It will just print the vector. And it actually, this print line actually works on ranges. So whatever range you have inside, you can just pass here and it will print, which means you can print with, work with maps, with vectors, with arrays, which is really nice. So it is quality of life improvement. It's the fact that you can just print any data structure. Let me just compile it and run. Well, obviously it doesn't just compile. Let me see what's wrong here. This is the fun part where we get like just forgot semicolon. All of this just for one semicolon. Okay, apparently something else is broken. So let's try to figure out. Usually scroll, transform. Okay, typo. Yeah, more probably someone mentioned is in the chat that I made a typo. Yeah, the color is different. I would have noticed, but I mentioned my color recognition is not the best. Hold on, now you don't have to iterate the vector. If you use print line, you actually don't have. So print line will just print the vector for you, and we can just see how it works. Did I not save the file? Line skipped. Called constable function. Okay. Oh. Yeah, I imported print. Should worked. We can try to do still print line of skips just for the sake. I wonder what's here. What's wrong is here. Class chicken smell vector int. I can't believe my deleted function formatter. Is my compiler again doing some tricks on me? Yeah, probably I should install Clang and ditch this GCC shenanigans. Otherwise, it's becoming too problematic to read all of these things. Yeah, that's a problem. Like, never know with C++ if you did something really stupid or if something smart is not working as expected. Okay, maybe we can do something different. Maybe it doesn't try cannot infer types properly. Let's do this. Just just for the sake of experimenting. It is actually a valid strategy. Sometimes when you're stuck, you can just do things that shouldn't change anything. Sometimes you're like not sure if they will do, but they might. And this is a great opportunity to pause and think that you don't understand something about this. Just about function. It's not a constant expression. How can it be this way? ChatGPT. We might need to ask ChatGPT, folks. We managed to survive three videos, 3 streams without asking ChatGPT, but looks like we should be able. We are not able to do this anymore. Give me a second. The worst thing is that I actually tried to do this before the stream just to make sure it works, but in a different environment. And this is like a pain in programming that you can just slightly change the environment and things will break, and it's not ideal anyway. Let's go and train ChatGPT on this beautiful functional code. Don't think template matters. Usually, but you can do lots of really weird things with templates. But like you can do really weird things with templates, but we are not there yet. Okay, ChatGPT is not copywriting. It allows me to it wants me to actually write this like separated by colon whatever manual printing. I'm not doing that. Like because I literally tried and it worked as expected. How old are you? Yes, senior Bloomberg. If I'm older, you're obligated to give me a job title. Unfortunately, this is not how it works. If you want my job title, you have to pass the interview. Come at Bloomberg, pass, and then we'll talk. You might get a nice error without that indirection. We might. Let's try. I tried to use like class template argument deduction and not specify the type here, but maybe this does some tricks with me. Who knows? Well, it does says that there is like no function to print, is that it uses like deleted formatter serialization for this type. So it does mean that it doesn't know how to format it, which I assume it is because the compiler is not modern enough, like it's not really the best one, and I do need to install Clang. I'm not going to do this on the stream, so looks like we are going to do this the hard way. And we need to do it manually. Anyway, it's a nice opportunity. Wait. Does it in the string model? Do I need to include this? Will it work? You never know if like hidden include suddenly fixes things. No, okay. I'm not insane. What are the taxes in UK for software engineers? Don't ask. You don't want to know. The taxes oh, actually this part was wrong. Forgot to update. One more try. No, still no. The grind continues. We will have to write function manually. Sorry, folks. I told you that you can print line vector just like this. Unfortunately, you have to update your compiler first. This is a reminder, like tip of the day. Put it on the poster, like somewhere in your room or in your office, and say it like update your compiler first. I have a like home now. I have my own homework for this week. Try to update, use Clang, and make sure it use. You want to use Clang anyway. It has a lots of nice tooling like Clang Tidy and all of this stuff. But anyway, we still need to survive. We need to finish our stream. No, I don't know how you convert anything to string. C++. Let's do just vector of ints. Should be doable. We're going to write it in a functional way anyway. So what I'm going to do is that I think I actually wrote this function on one of my previous streams. So let's see if I can recreate if all of this functional programming knowledge is reproducible. Now by some int. So we want to convert x to string, which is not number. God, how do you do this? Do you have like e to s integer to string? Hold on. Okay, this should work. Apparently there is a standard function to string, which is nice. We're going to return the string. So basically converting vector to range of strings, and we are going to join. With commas, so there is a actually nice useful function join with, and then we are going to combine them to string. So this is our nice string transformation. Okay, let's see if it works. Print line to str of escape. Oh my god, are you being so annoying? Thanks for having a good stream. we're, we are having some challenges here, but anyway. Yeah, I hope your C++ programming um, goes better. No need for the lambdas. Can we just pass the function? So this is my struggle. Um, Sometimes, like, um, it doesn't really work well with the function. So in proper functional programming, functions, lambdas, they're kind of uniform object. In C++, lambdas are kind of separate structures with this operator, and they're not always interchangeable. So when I play in like um, in my free time, functions don't work. Maybe some functions have more overloading, and they actually support just passing functions, but generally, it's a problem. Yeah, apparently, like string literals require a constructor. Okay, we finally managed to make it compile, but you see that the result we are seeing is not what we wanted. So we don't skip every second element. So the first one is correct. Then we start with the first, and then we skip like one element and continue with the third, and so on. So this is how stride in C++ works. It actually starts with the first element always, and then it skips the given number of elements. So what we want to do, we want to first skip a few elements and then stride with the n. So we are going to do std views drop, and if we are starting, let's say, with the third element, we want to skip two, so 1, 2, and the third. So here we are just going to do n minus 1, and then we pipe it to the stride. And if we do this, now we see that the correct result when we skip every first element, so nothing, we get 1 to 6 every second element, 2, 4, 6 every third, 3, 6, 4, 5, 6. So it works actually. Despite not being able to leverage standard print function, everything kinda worked. So anyway, this is how we can solve the skips in a functional way. Someone mentioned using std ranges here as well, and I think that was a great suggestion, and let's actually do this. Instead of having this separate transform lambda that does this like range begin, we can just copy these ranges here. And we don't need this. And this is kind of still functional style, but you see that you have this like pipeline of transformations, and they can be nested, and you can actually separate this lambda into a separate function. You can have a separate function like to skip just starting from 1, that just gives the vector and the number, and then you do this, and it becomes like simple 3-line pipeline. But overall, you see that we don't have to worry about like for loops. We don't have to worry about indexes. Like imagine like this stride, you need to skip every n element and then make sure you don't overgo to the boundary and so on. This is like correct by construction. Like we don't need to worry about indexes. We can just declaratively describe how we transform our data, and we get a lot of this out of the box. This is really nice. Let's make sure it still works. Okay. One nice feature I want to mention, which I also learned not so long ago. So here we kind of converted like string literal to string, because this is like const char. It actually, if you hover, it says it's const char 3, so it's array of characters. And but here we do string, and join with doesn't really work, so we have to convert like this literal to string. So C++, I think C++ 11 introduced this feature of custom user literals, and basically it moved C++ even closer to Haskell. You can actually almost overload the definition of this string. So you can tell the compiler to interpret this as a string without invoking constructor. And to do this, you need to import this thing. I think it's just string. Why doesn't not like it? And space is not allowed. Yeah. So this thing contains custom literals for strings, and you mentioned there was like string views. So here, if you have it, you can write thing like this, and this will become now state string. So instead of wrapping it in a constructor, really verbose, you can just add the s suffix to your string literal, and this will become a string. And as long as you have this like imported from this namespace, the literal string literals, you can actually have this as a string. And oh my god, not Microsoft. And it still works. So this is like a nice feature to introduce to use literals and like make types match to the way you want. Anyway, that was the first problem. Let's go to the second one. So we've done with this one, and we verified during printing that it works. Exercise 2, local maximum. A local maximum of a list is an element of the list which is strictly greater than both of the elements immediately before and after it. For example, in the list 2, 3, 4, 1, 5, the only local maximum is 4 because it is greater than the elements immediately before and after it, 3 and 1. 5 is not local maximum since there is no element that comes after it. Write the function local maxima integer to integer, list of integers to list of integers, which finds all of the local maxima in the input list and returns them in order. For example, 2, 9, 5, 6, 1, local maximums 9 and 6, because 9 is bigger than 2 and 5, and 6 is bigger than 5 and 1. Here we have only 4, and here we don't have any local maximums. So let's write this function. Basically, the solution here, again, we will write it in a functional way, and the idea is the same. Do you listen to ADSP, the podcast? I don't listen to this podcast. I don't even know this podcast. If you can share the link, maybe I can check it out later, but I'm not familiar. So for local maximum, we are going to work directly with numbers, which is integers. So we will take a vector of integers and we will return a vector of integers as well. So no templates this time. Again, we are going to pass vector of integers by reference. Nothing really new. So here we're actually going to use, surprise, surprise, another standard C++ function. Let me just show it to you on the CPP reference. So there is actually already slide which provides you the sliding window, and the way to find this local maximum here is basically we're just going to use sliding window of 3. So we will just look at these 3 elements, at these 3 elements, at these 3, and we will just compare the middle element with like its neighbors. And if it's bigger than its neighbors, then it's a local maximum. And C++ already provides this function sliding window, and there is this example. Let's say if you have this like vector 1, 2, 3, 4, 5, 6, and you have this sliding window of 3, then you actually will have every sliding window of 3. Hey Shreyas, thank you for joining. Anti-FP propaganda boy. It's not anti, we're actually solving everything in a functional way. It is the functional programming propaganda. We're actually trying to solve everything in functional and declarative way as much as possible. And thanks for sharing the ADSP algorithms, data structures equals to programs. I'm watching another algorithms and data structures playlist right now, which created by Pavel Maurin. He is teaching algorithms in Etmo University where I studied, and he's really smart. He does competitive programming and he explains really well. So I'm good on my data structures and algorithms content. But as for this problem, for functional programming in C++, there is not enough content, and we are actually going to fix this. So let's find local maximum with this sliding window approach. So basically, what we want to do, we will run the sliding window of 3. We will just check every element, and we will return every element of this. So let's do exactly that. The programmer is Pavel Maurin. He has a channel on YouTube. I think you should be able to find it with this name. So the approach is kind of similar. You see how we have this, all of our functional programming, all of these function programs, basically just pipelines. We transform the data through these pipelines, and it is like generally a good approach to start. So we have vector, and we will pipe it through speed views slide, and it requires the size of a sliding window. We will pass 3, which is just hard-coded, and then I want to transform this. I kind of want to do 2 steps at the same time, but I will going to do it separately. So first of all, so now I have a range of sliding windows, and I want to keep only those sliding windows that contain local maximum, and then later I want to extract this local maximum from those sliding windows. So let's actually do this in 2 steps. This like filter map approach. We're going to do views filter, and this is going to be just let's call it window, sliding window. So we are having this window, and I want to keep only those windows where the middle element is bigger than its neighbors. So the great thing here is that windows, actually like this range window is a range and has iterators, and I think in slide it's a good iterator, or because it's a vector, it's a big beautiful iterator, and it means we can access elements by index. So I can say if window of 0 is less than window of 1, and window of 1 is bigger than window of 2, so this is kind of the good sliding window. I will keep it, and then I'm going to do studios transform. Again, I don't need capture. Now I have a now I have properly filtered windows, and I want to extract the first element of this window, so I just return window 1. And again, we are going to assemble everything to vector. So basically, this is like how you find local maximums in a couple of lines of declarative code, like do sliding window with size 3, then filter for relevant windows, and then just extract the window you want and assemble it to the vector. So let's actually try to test if it works. So we will have vector 1, it's like 3. We have vector 2. Let me just copy the test cases from the coursework. Shouldn't take too long. Nicely formatted. Hey, first time watching, I want to ask if I still don't understand the docs about certain code. Is it okay to just look at other projects that use the code? Yeah, I think that's kind of like the issue with C++, so that reading actually docs and fully understanding them and like type signatures, it requires a bit of onboarding because the standard library tries to solve lots of difficult problems. It tries to be generic and it's not always easy to read it. So I usually just read examples. So if you go to CPP reference, you will find examples, and generally just following examples is great. You can ask AI to figure out if you're stuck with errors. That's what we did earlier when we were stuck. Um, so, and yeah, or you can read like other code, you can find something on GitHub. It's totally fine to see how it use it. And eventually it's kind of like example driven thing. You read more examples and you realize. Did this problem specify what to do with equal values? E.g. 1 to 2, 1 is 2 a local maximum. Um, let's take a look. So the problem says strictly greater than both of the elements. So for equal values, it means it's not local maximum, it won't be considered. So in the task it says strictly greater. If you don't want to be like strictly greater, you just replace less or equal with, less or greater with less or equal and greater or equal. So not really a big challenge. Anyway, where was I? Yeah, I want to do some tests. Okay, so far no name conflicts, which means that it should work. And I'm just going to print line our result. So now we have a function to print vector of integers. So hopefully we should be able to just reuse it. To string of local maxima of vector 1. Okay. Yeah, let's see. If it works, if it compiles and runs. Okay, nice. First time, we improved our range knowledge. Compiled first time, run first time correctly. Excellent work, everyone. What is the transform for in this function? So transform actually extracts local maximum. So when you have like the slide, it transforms it to slides in windows, which you can think like arrays of size 3. So we don't want the arrays of size 3. It's not arrays, it's ranges. That's why I'm using auto not to specify the type and not to care here. But it is like the, like you see, these things that I can iterate. And yeah, I'm first filtering to just keep all of the elements, and then I'm extracting. So this idiom of filter and transform, it's really common in functional programming. So there's like actually a function which is literally called filter map. I think it's not in C++ yet. Maybe it will be added eventually, but it actually allows you to filter and transform in one step and automatically do the thing. And it's it's really useful. I hope functional programming in C++ will catch up with this. I would love to see profiling results between the same exact code execution results between Haskell and C++. I think Haskell code would be faster, just guessing though. So these ranges actually in C++ are really optimized. So they are lazy, the same as in Haskell, and they actually use like compile time things and iterators, and they're almost like no overhead. So I actually doubt Haskell will be better here because it is actually the same as in Haskell, but there is no boxing overhead, there is no like garbage collector overhead, no extra allocations, and using the C++ compiler and all of the low-level optimizations it can afford. So this is actually one reason where in C++ you can get benefits. You can still write in this declarative functional style, but you can benefit from optimization performance. If it becomes really slow, then you might want to rewrite it to actual loops, like for loops, but unless you are doing, some high frequency trading or really some low level stuff where you really need to squeeze every microsecond. This should be good enough. It kind of allows you to be productive. So you see, we just wrote a couple lines of code. You really easily get this function. It works well, and under the hood it uses like nice abstraction, so it's really nice. Yeah, so this is actually just constructing the pipeline and then we'll evaluating and correcting. And again, maybe you don't want vector, maybe you want something else. C++ is really flexible and allows you to do a lot of these things. So yeah, I think we are doing great on time, and there is only one exercise left in this homework. It's pretty small. I checked some upcoming homeworks. Some of them will be tough. I already see how one of the homework will span 5 videos and 5 streams because they decided to just like give all of the type classes like foldable and monoid and semi-groups in one homework. Oh boy, it will take a while to actually go through that one, but this one is easy. So let's finish the last exercise and complete with it. Exercise 3, histogram. For this task, write a function histogram from list of integer to string, which takes as input a list of integers between 0 and 9 inclusive, and outputs a vertical histogram showing how many of each number were in the input list. You may assume that the input list doesn't contain any numbers less than 0 or greater than 9. That is, it does not matter what your function does since the input contains such numbers. Your output must exactly match the output shown in the example below. So here we have histogram 1115, and it draws this like really simple ASCII art. So there are 3 ones, which means there are 3 stars above 1. And there is 1 5, which means there are like 1 star above 5. And if there is like slightly more convoluted histogram than this, I'm not going to count all of this. I hope it's correct, but you get the idea. It's basically is to draw this simple thing. It feels like an advent of code problem to me. So it's something you would normally do in write, not really simple. I think if it were advent of code, it would require you to do the opposite, to parse this histogram. So you're given this string and you need to return this list numbers, or maybe like find the sum of digits or whatever, find the total sum of numbers. So this would be proper histogram, and it will be like Christmas tree, and yeah, I can see it. Anyway, the point is to write an important note, but the important note is about Haskell, so not relevant to us. Yeah, I did work in the UK, so I'm in the UK for about like 5 years. But before UK, I was in Singapore, I was in Russia, I worked in all of those countries. It was fun. I can recommend traveling to everyone. It's really nice to meet new people, make friends, learn new culture. It really expands uh, your way. It's good. Yes, I do post the streams on YouTube. So YouTube takes some time to process, so they're not immediately available on YouTube. And well, once it's published on YouTube, you cannot really participate. Now you have time to kind of ask all your questions, do some exclusive content. But eventually, yeah, you will be able to see everything on YouTube. So whatever we wrote will be there. Yeah, Singapore is expensive, but they also have really low taxes, which is nice. But overall, it's a really nice place. It's really modern. I like it there. Maybe it would be nice to live there one day again, but we'll see. Anyway, going back to histogram. So this one is a little bit trickier. Because it will require like a lots of data processing, and I think you can write some high-level functions how to print this. I just want to get done with it. I will use maybe a little bit of functional programming, but because like I think in Rages there are not the same functions as in Haskell, and it will be really difficult to do. So anyway, we want to return just one string, and we are taking the vector of digits, but they're just numbers. We don't need int, so technically if you were to optimize, you would use some like one byte type that contains digits or something else. But again, this is just exercises, and we are just learning functional programming. So the idea is that we want to go through this vector, and we want to just count how many times each digit appears. So it's a really simple count, and then we kind of want to output as many stars as the digit. So again, go through all of this, but there is a little bit challenge. So you can easily like convert a number to like to string by repeating the string several times. But the problem is that you will get this like string horizontal, so it's not the same. We kind of wanted to have like a vertical bar, and so one way you could do this, and you can kind of concatenate all of the strings horizontally, and then you can transform the vector, so you can kind of rotate the matrix by 90 degrees or whatever. This is one way to do it, and this will, I think this is what kind of the Haskell solution will be. So you do this the function to actually repeat character, and there is a transform function which actually, oh no, it's called transpose. It does this like matrix rotation, and then you can use it. It will be really nice. I don't think it's in C++, so I'm not going to do it. But anyway, let's try to do it somehow just to have something working. And again, this is an example. Sometimes if you don't know anything, if functional programming approach doesn't really work, you can always fall back to the previous one. You see here, it's like nice to have this declarative pipelines. You have transformed data. Sometimes you may need to do several steps. So first of all, I will have an array of counts. It will be an array of size 10, and this is basically how we will calculate every element. I'm going to iterate through every element of the vector, and I'm going to just say that count of n is just plus plus. Okay, we can write it shorter for the spirit of code golf. We can think later how to do this in a more functional way, again, but sometimes if code is really simple and for loop, like everyone understands what it does, in this case, it's not really easy. You don't start from one thing and you transform it constantly to another. You kind of have independent steps. So first we count and then we print. And I'm going to, okay. I'm going to have a vector of strings, and here I can actually use the same trick. So this will be like the graph, and I can immediately start with with some strings hard-coded that are already known. So first of all, 1, 2, 3, 4, 5, 6, 7, 8, 9, and we'll add suffix s, will be like a vector of strings, and I know that there will be like 10 equal signs. So it's really hard for me to count to 10. So what I'm going to do, I'm just going to do this. Oops. Okay, didn't work. This, and I need to replace with not plus, this equality. Okay, now we have 10 equal signs, and then basically I'm just going to add more elements to this vector by leveraging this count array. So there are different ways to do it, but in the end, you kind of still want to, how would I say, So you will print this vertical graph. We don't really care about I would say performance in this case and how to allocate as little as possible. So what we can do, so there is one of those numbers in counter is the biggest, which means you will have to print at least as many stars as the biggest number in this array. So let's actually find the biggest number. So we calculated count and we will say maximum is, I think instead ranges, yeah, maybe it's actually in algorithms. So in ranges, they implemented almost like 200 algorithms and they copied the standard like STL algorithms. So basically, if you have anything in STL, you should be able to do it in ranges as well. So you should be able to just do this. So if you want to find the maximum element in a container, you can just do this. And why does it complain? Does it actually want max? Okay. So this is kind of like the maximum element of this array. And what I'm going to do is that I'm going to iterate through 1 to maximum, and I'm going to iterate for every digit, and I will put like either star or space for this digit if this number is bigger or equal than counter. So let me just write it for int I from 0, I less than actually let's do this less than equal than max, and we'll do plus I. Then for digit starting from 0 up to 9, going to create an empty string, and basically if count of the current digit is bigger or equal than I, so I is kind of like the current height. We can actually, let's rename it to H, because it's like a proper name. So if the counter is bigger than H, then I'm just going to add a star to line. Otherwise, I'm going to add a space to line. You can kind of again code golf it. So we can write something like this. Actually do this. If count is bigger, then let's use ternary operator. Why plus? It says star. Okay, so we basically will construct a line, and then I'm going just to push this line till the end of the vector. Would you say the unilateral parsing of your code is affecting the efficiency of your code base? If so, would you implement any AGI optimizations over bilateral training model? Sorry, I speak only English. I don't understand what does it mean. Anyway, let's get back. So we basically constructed our histogram, and now we want to output it. So here we can actually leverage some functional programming. So I want to kind of concatenate this graph line by line, but I want to start from the end. So you see, this should be the last line. If you look at the example, it will be like the last line, and then the equality, and then all of the histograms and the biggest bet. So I actually want to view this in reverse, and this is what we are going to do. There is actually the reverse function, and it's reverse, and it doesn't actually reverse the in place. It just kind of provides the reverse iterators, does the stuff, and it fallbacks all of this in the reverse. So it is really nice. We already used the join these. So basically, I just want to combine them as a line, which means I can use combination with n, and I can use against string literal s to do this. And since I have like the join with returns kind of like range, and that's why I need to do ranges to string to convert it to string. So we did a little bit of functional programming at the end, and you can see this is how you can kind of write as a program. Sometimes you write this imperative code with like for loops and some nested stuff. Sorry, because it's easier. But then you kind of want to declaratively transform the data, and this is how I usually think about problems. So if I see this pipeline, if I see how the data flows through all of the steps, which kind of declaratively defined, then I would use this functional style because it is shorter, it reads cleaner to me and stuff, but sometimes it's not possible. So I do think, so this actually is possible to do too in a functional style if you have helper function. So this is basically you want to repeat some action multiple times and you want to aggregate results. So this is almost like for each for things. So you can, again, you can try to generate iota from 1 to maximum. So you kind of want to map this to every line, and then here from 1 to 9, again, you can use iota and you can use like counter depending on this. So it is possible to do this in functional style. So I think sometimes it's not worth it. It might be less readable. So here you can kind of see what's going on, what's the counter, and it won't really be shorter. Here you can see everyone is one line, and again, it's really nice even when you don't use lambdas, you just transform and it just looks like a proper time. Anyway, just like weird aesthetics. But let's try to actually do some tests. Exercise 3, histogram, and let's actually copy examples from the course. I'm not going to add spaces here for the sake of saving time. The implementation says that do anything, like don't worry if numbers are bigger than 10 or less than 0, so I'm also not worried. And now, because it's a string, then it should actually work with just print line. So if I print line the histogram of h1 and the histogram of h2, it should work. Let's see how it actually behaves. Okay, it looped probably forever, which means we have an infinite loop, which probably means I messed up with some of the loops. Probably some condition is weird. I'm interested in C++, but not that much in the FP. Will you do another series teaching more general C++? So I am teaching some C++ here as well. Like if you use ranges, like you might find them in the code bases, and actually I see push more towards this direction. So it's really good to know how they work. You know, little features like string literals, the fact that you can do this, it's nice. I view this like language features more like an addition to what you want to do. So you want to solve the actual problem, and there are all these different tools to solve this problem, and you just want to use them. Yeah, hey, yes, it's me from Twitter. I'm actually from real world, from planet Earth, specifically from the UK and London, but yes, I'm known to be in Twitter as well. This is annoying. Okay, let's do debugging. Let's hope it will work. I think I tried. Mm, okay. Yeah, I think my debugger is not configured, so we will do the good old print line debugger. And oh, why hasn't it complete type? Ah, I think this is my C++ knowledge, the one that you mentioned, and yes, since it's not initialized. Uh, yeah, I guess it's not initialized, so it just takes random garbage from stack. And how can it do this? Can I avoid repeating 10 zeros? Um, can I do fill? Yeah, I will do this. Should work now. Okay, now we have really nice histograms, and they seem to do the same um, as in the example in the course. So yeah, nice thing about ranges is that you actually have kind of alternative to all STL algorithms, but they simply that you don't need to pass begin innate iterator now. You can just pass the range, and it will kind of automatically will do begin and end. To me, it feels kind of weird that C++ got this only in the end, like how you have to do this, you pass these iterators, begin and end, all the time, which to me sounds like a low-hanging fruit, like an obvious opportunity. But I guess due to different complications in C++, it just take a while to figure out proper abstractions, and ranges do this. It allows you all algorithms to work with begin and end. All of these things like should work with the print line should also work. We shouldn't need to do this to string. Again, maybe my compiler is really old, and yeah, debugger broke my IDE, so I will have to figure out anyway. I'm glad we did it just now. um, and everything works so far, and yeah, we finished this course. It was a little bit lightweight, so no binary search trees, no nothing really complicated, and yeah, hope you enjoyed the functional programming. You've seen how to solve a little bit of problems, and yeah, we did some exploration. And next time there will be more of that. So the course is not finished. I am committed to actually finishing this course and go through every single homework there, try to solve in C++, and you can see that we can use a lot of functional programming features already. So is VS Code your main editor, or is it just for the stream? It is my main editor, so I use everything there. As you've seen, I use like vmod in VS Code, so it makes editing easier for me. I don't just type code. Sometimes it makes harder, but you know, no pain, no gain. You have to earn it. And we will do monads, don't worry. So this Haskell course, it actually teaches proper Haskell. So there is like folds, like proper folds, like there's trees, algebraic data type, there are monoids and semigroups. These are really great abstractors. I really like them actually even more than monads. But there is parser combinators, which is a really great way to parse data. And obviously the final task will be the monads. And the type classes, we will look at the C++ features like concepts. So at some point I am going to explain what is a concept, how it works. It is similar to type classes in C++. And yeah, I will explain some of these features from time to time as we use them to solve different problems. Is C++ a good bet for today's job market? I think it is, yeah, because if you, let's say, look at the TOB index, C++ is the second most popular programming language. So the first one is Python, then C++, and then whatever, doesn't matter, whatever other languages below the second place, but it is fast. And mainstream programming languages are imperative nowadays, so like Java, C Sharp, Python, TypeScript, Go, um, what else, PHP, they're all kind of imperative in the same style. So I think C++, in some sense, kind of the hardest of them all. So all of the languages except Rust, they has like garbage collector. So you don't have to worry about like passing by reference, by pointers, specifying proper destructors, things like initialized memory, how we have here, like some other things. So it makes things simpler in other languages. So if you know C++, you can actually pretty easy learn everything else. So for me, if I want to learn, let's say Ruby, I don't think I will need like more than like a evening to actually be able to write Ruby. Um it will take more than that to, let's say, understand Ruby on Rails and to familiarize with all of the frameworks, because there are some ideas and they are reusable. And like if you know this idea, if you met this once, you can actually use it. So that's why this like ranges and functional programming in C++, it's easy for me because I've been programming in Haskell and OCaml for 10 years. Like it's basically what I did my whole life. I've been paid for just writing lots of these pipelines. And for me, it's like straightforward what's done, and I don't need a lot of time to actually understand. There are like specifics, some like names of the functions are different, some how like types of work, like some API things and like standards, how they change between different standards. These things kind of I need still to learn, but overall, as long as you know ideas, it's really easy. And yeah, C++ is really good. And C++, I think it also can be used in diverse areas because it provides you performance. You can use it in game development. So if you're interested into that, game development requires a lot of like optimizations. It's used a lot in finances, on backends. So let's say if you lots of like financial firms use it for sometimes for historical reasons, but they also a lot of them require performance, and C++ is a language if you want the best performance. And what else? If you want to write backend really fast, so for most web, I guess I think you don't need, but let's say if you are Google, Google requires really fast search because billions of people do using it every day, and you want to process data really fast. Or if you AI, so I can imagine that ChatGPT also processes a lot of data, and they also need to do C++ and lots of other AI agents or lots of things you use. Let's say I think Google Chrome browser might also be written, and C++, a lot of the things they really need to do this. So I think it's a good bet. There are lots of diverse. C++ is for the big guys. Yeah, we all grown up at some point. Some encryption algorithms in Haskell would be awesome. Yeah, you can have a look. I think some people did some encryption. There's like I forgot how it's called, like homeomorphic encryption or something like that, like some algebraic encryption. There are some interesting features people do with encryption and functional programming. And yeah, Haskell, it has a garbage collector, so like it's in some sense a little bit harder to like violate memory and do this stuff. And yeah, when you don't really care about performance that much, you just want to make sure to get it right, then a language like Rust or Haskell might be a good thing. So do you think Rust will grow in the job market and feel the demand is heavily towards web development, cloud and data science right now? So Rust is growing. I am seeing more job opportunities in Rust today than, let's say, before, because lots of people are passionate about Rust. They write their open source projects in Rust, and they're trying to push it in their companies. So for example, I've seen Rust more in financial companies than, let's say, other languages like OCaml. Let's say in financial companies you will see Python, C++, Rust, not much anything else. So Rust definitely is present on the job market. Will it grow? It's hard to say because there is like a ton of legacy C++ code, and Rust is kind of antagonistic to C++. Its core principle is to rewrite. It's not compatible because, well, it does make sense. Like if you're trying to integrate with legacy, you have to be less safe because God knows what it does. But on the other hand, it does require you that you cannot easily just rewrite some parts. You maybe if you extract into separate projects, then you can uh, kind of try to rewrite those projects. But then if it's kind of working, why rewrite at all? So it maybe if you start a new project, you want to add more features, and you realize that the cost of development will be much, much bigger than the cost of rewrites, and maybe it's a good opportunity to rewrite, and people are pushing. I don't know if it will grow, because I remember it was similar with Haskell. Haskell at some point, it really had momentum, so it started growing rapidly. It became more popular. People started to talk about it, and there are lots of open source projects. The build tooling is improved, and circa 2015, it felt like Haskell could be a really new thing. A lot of people are passionate, and it's starting to finally shape up. The ecosystem become bigger, and there was this kind of momentum, but it got lost for different reasons. Didn't just get enough critical mass. So I guess we'll see. A lot of companies, I mean, who use C++, they have legacy C++ code bases, and they are growing. So people do write C++, and it's increasing, and there is demand to actually support the stuff, to migrate to new C++ standards, to leverage all of these features, all of these pipelines, which is really nice. Hi, take Candy, or take Candle. I guess I will happy to take both, but just joined, but we actually almost finishing this stream. I just walked through several problems. You will be able to watch them on YouTube later. Overall, but yeah, we are almost wrapping up. Did you ever do CP? I hope you mean competitive programming when you say CP, but I did do competitive programming at some point. So this is how I started. I started learning programming just for the sake of competitive programming. They were like a lots of competitions, and if you want to go to top universities, top colleges, you kind of have to be the top among those competitions. You cannot just pass exams, so like write essays. It's not good enough. So I wasn't really that great. So some people, they start really early, they maybe have support, and they're also smart, they understand. So I didn't do a lot of those, so I understand like some simple algorithms, and it was good enough for me to actually pass. But then I've seen that some people like are really smart, and they spend a lot of time training and practicing. So I kind of stopped doing competitive programming and focused on learning programming, learning just generic stuff, getting a job and doing this stuff. But it was fun. I do hope one day maybe I can do more of that. It could be nice, maybe in functional programming. Anyway, thank you for lurking. Any view, is appreciated. It's nice. I don't stream daily. I stream weekly. So every week on Saturday around this time. So starting from 3 p.m. UTC for 2 hours approximately. Um, Streaming does require lots of time. I have other responsibilities, but once a week for now is good. If a thing goes really good, I might stream more. So if you're watching me, if you're supporting my content, that means really a lot to me. Um, for now, it's good. Anyway, I've been talking for too much. You folks had to listen me for way too long. I'm going to wrap up, and yeah. Anyway, I guess see you next week, and thank you for joining. Bye.